In this video, we're going to take a quick break from building out the REST API, and instead, we're going to cover a more advanced promise concept. This is promise chaining. So we've had a dozen or so videos to work with the basics of promises, and every time we've used them, we've done just a single asynchronous thing. Right here, for example, we do one asynchronous thing, which is to find a user by their ID, and down below, we also do just one asynchronous thing. We save the new task. What if we wanted to do one thing and then something else, like geocode an address, then fetch the weather for that location, or mark a task as complete and then get the total number of incomplete tasks I still have to do? In both of those cases, we're working with two asynchronous operations where one needs to happen and then another. Now, promises do provide an advanced syntax for actually getting that done. Before we worry about integrating it into our application, we're going to mess around with it over in the playground directory. We have that promises file we've used plenty of times so far, and we're going to spend a little more time in here learning this advanced syntax. As always, let's get started with a promise that uses setTimeout to simulate an asynchronous delay. Once we're comfortable with the syntax, we'll integrate it back into reality and use it with the promises that Mongoose provides. For the moment though, we can just clean this file out, and we're going to create a new function called add. Add is going to take in two numbers. We can accept A and B as the parameters for add, and all we're going to do is return a promise. After 2 seconds, that promise will be fulfilled with the sum. So right here, return new promise. We are going to set up the promise function. This is where we get access to resolve and reject. Then we're going to wait those 2 seconds, providing the function to run and the 2000 millisecond delay down below. And the last thing we put inside of here is a call to resolve, and we're going to pass in a single argument, the sum of A plus B. Perfect. Now that we have this in place, we know how we could go through the process of using this a single time. I could call add, passing in a couple of numbers. I'll pass in 1 and 2, the sum being 3. Then I can add on my then method call to do something when the promise is fulfilled, and I can add on my catch method call to do something when that promise is rejected. So right here, I would get access to the sum, and I could use it, and down below, I would get access to the error, and I could go ahead and just log it out. Now for the moment, we'll also log out that sum, so console.log sum. Now I went a little quickly setting that up because this is all stuff we've done before. From here though, we'll be exploring new concepts. Let's take a quick moment to run the program to make sure it's working before we continue on. Down below, I'm going to shut down NodeMon, which is running the Task Manager app. I'll use cd:/playground to navigate into the correct directory. Then we can use node with 8-promises.js. Now, when I run it, I would expect to wait for 2 seconds, then see the number 3 print, and that is exactly what I'm getting right here. Now, in this case, we are indeed performing a single asynchronous operation. We have added 2 numbers together. What we're going to do from here is take that sum and use it with add again to add another number into the mix. So that'll be 2 calls to add, or 2 asynchronous operations. Now, if you didn't know about promise chaining, you could still solve this problem. You would just go where you have the sum and add another call to add. Where do I have the sum? It's right here inside of this function, and I'll add another call to add. I'll set up the call to add. I'll provide the sum as the first argument, and I'll provide the other number I'm trying to add as the second, in this case 5. I then set up another call to then. Right here, I get access to what I'll call sum2, the second sum, and then I could also add on a catch call to handle any errors from that. Once again, console.log the error if anything goes wrong, and if I do get that second sum, I'll log that out as well, sum2. So right here, I've just taken another promise call and I've nested it inside of my first one. Now, if I save the program, this is indeed going to work. I can rerun the script. I'll wait 2 seconds to see the number 3, and then 2 more seconds to see the number 8, and that's exactly what I get. Now, the problem with the above solution is similar to the problem we ran into when using the callback pattern without promises. The problem is that the more asynchronous tasks we try to perform, the more nested and complex our code gets. For example, we're doing 2 asynchronous tasks, so we're 2 levels deep nested. If we were to add on another asynchronous call, it would get even more complex. We also have duplicate code for catching errors, which is not ideal either. There's a better way to get it done using something called promise chaining. Let's go ahead and explore how we can recreate this example using the new syntax. What I'm going to do is comment out the example up above, though I'll leave it in place so we can compare and contrast the 2 solutions. To use promise chaining, things start off exactly the same, so I'm still going to call add, and I'm still going to pick a couple of numbers to add. I'll add 1 and 1 for a sum of 2. Right here, I still call then, and I provide my function allowing me to do something when the promise is fulfilled. I'll get access to the sum, and I'll just keep the examples consistent. So right here, I am going to log the sum out so we can track things as the code runs. Now we have access to the sum, and we want to add that second add call into the mix. When we're using promise chaining, what we do is we return the next promise from our then callback. So right here, what I need to do is return a promise. So what I'm going to do is return whatever comes back from calling add, which I know is a promise because I set that function up moments ago. And right here, what I'm going to do is add the sum with another number. So I have the sum, which is 2. I'll go ahead and add 4 for a total of 6. Now the question is, where do we put our other then call? In the previous example, we put it inside of the other callback, and that's what created this problem where we had all of these nested callback functions where each asynchronous process would get us further and further nested as we moved on. With promise chaining, the second then call comes right here after the first. So .then, we then get access to the result of that promise, the result of this promise right here being fulfilled. I'm going to call that sum2. I'll set up my then call, and right here, I'm just going to console.log it to the terminal like I had done in my example up above. So this is promise chaining in effect. It's chaining because what I'm doing is chaining together multiple then calls, each working with a different promise. The first then call runs when this promise right here is fulfilled. The second then call runs when this promise right here is fulfilled, and we could add on a catch call at the end to catch those errors. So right here, I'm going to provide a function similar to what I had up above, but I'm going to provide it just a single time, console.log, printing any potential errors to the screen. Now, the nice thing about promise chaining is our code is not nested. I could chain together 400 calls to add, and it would never get nested. Imagine 400 calls to add using the example up above. Now, 400 is a bit extreme, but even with 2, it's clear that we have advantages, and if we added a third into the mix, it would be even more advantageous. Let's go ahead and run the program to make sure it's still working. Up and then enter. Right here, we wait our 2 seconds for the number 2, then we wait 2 more seconds for the number 6. So right here, with promise chaining, we're able to achieve something similar to what we had above, but with an improved syntax. All you need to know is that you can return a promise from one of your then callbacks, allowing you to chain another then call on. So that is the promise chaining syntax in isolation. Let's go ahead and actually use it with our tasks. Now, there's not a real use case for it just yet inside of our REST API. So what we're actually going to do is create a new directory in the task manager folder. Right here, I'm going to create a new folder, and we're going to create a playground directory specific to the task manager app. And in there, we're going to create a new file called promise-chaining.js, and we're going to use this file to explore how we can work with Mongoose promises and the chaining syntax. Now we only need two things inside of here. First up, I do need to require that Mongoose file to connect to the database. That's cd, not cd, just /source/db/mongoose. Now that we have the database connection, we want to grab the model we'll be working with. I'll be working with the user, so I'll require that as well. /source/models/user. So now we have access to the user, and we're going to go ahead and use a couple of new queries that Mongoose supports to do something interesting. What I'm going to do is change the age for a user. Then I'm going to fetch the total number of other users that have that same age. Let's start by grabbing the ID of the user we're trying to update. So over in Robo3T, we can grab any of our user IDs. I'll switch over to the table view. Now the age for every single user is 0, so it doesn't really matter which one I update. I'm going to right-click one of my documents, click Edit Document, and I'm going to copy the string object ID to the clipboard. We can bring that over to Visual Studio Code, and I'll go ahead and just paste it right here in a comment, and we'll use it in a moment. Next up, we have to figure out which Mongoose methods we're actually going to use to get all of this done. For that, we want to head back over to the documentation in the browser, and under that queries documentation where we were before, we have a few different options for doing this. I have update one and update many, but I also have find one and update and find by ID and update. Now the find variations simply return the document as well. So these ones down below, they're not going to give you the document back. Find by ID and update will, and so will find one and update. So it's really up to you which one you choose to use. I'm going to go ahead and use find by ID and update, so I'll click that to get brought over to the documentation. Now we can go ahead and actually use this. We are going to call user.findById and update, and the first argument we provide is our ID. So I have the ID right here. I'm going to cut it out, remove the extra lines, and I'll paste it right inside of a string as the first argument to our method. Now the second argument is the object which contains the updates we want to apply. In this case, I'm going to set the user's age from 0 over to 1. Now you'll notice that I'm not using that $set update operator we explored with the MongoDB native driver. The Mongoose library actually takes care of this for us, so we don't have to do that, which is a nice feature. Next up, we can go ahead and use then. So .then to run some code when we have found and updated the given document. I'm going to have access to that. I can call this something like user. And down below, all I'm going to do is print them to the console. Excellent. From here, we want to perform that second asynchronous operation, which is to count up all of the users that have that same age. So all users whose age is 1. Mongoose provides us with a method to get that done as well. Now over in that queries documentation, they show us a list of methods that are available on our model. This is not a complete list. This is just some of the most popular ones that are used to get common tasks done. This is in the guides documentation, which is more like a tutorial. Down below in API, we get the actual implementation for every single method available. If we click on model, we can explore these as well as many others. So I'm going to navigate over to the model API docs, and down below we have a bunch of different ones, including the one that we just used, find by ID and update, sitting right here. Now the method that we're here to use is up top a little bit. It is called count documents. Now we also have count, but count is deprecated and it'll be going away at some point in the future. Count documents is going to allow us to count up the number of documents. Now right here, we can see they have an adventure model, and they're trying to find the amount of adventures that have a type of jungle. We're going to do something similar, but with an age of 1 for the user model. Over inside of promisechaining.js, let's get this done. Now remember, the whole goal is to use chaining So I want to return the next promise. Return user dot count documents. And count documents works by accepting an object. Right here, we provide our filter where age equals 1. And what we eventually get back, the promise is fulfilled with the count. So right here, I'll add on my second then call, chaining it on to the first. I'll set up my callback function, and then we're going to go ahead and get access to the result, and we'll print it to the terminal. Excellent. Down below, we'll also set up a catch call at the very end to handle any errors from either of those two promises up above. Right here, I'll set that up, and I'll use console.log with E to get that done. Perfect. So now that we have this in place, we can actually test our work and make sure everything's actually functioning. Down below, from the terminal, we need to navigate out of the playground directory, so cd ... and back over to the Task Manager app. Once we're here, we'll go ahead and run the new file. That would be node playground /promisechaining.js. Now, when we run the script, we're going to get some interesting output. The first thing we're going to see is actually a deprecation warning, which we'll address in just a moment. After that, we get the document that we found. So that's printing from line 5, which looks great. And then after that, we get the number 1. That is the count. There is one user with an age of 1. It is the user that I just updated. Now let's take another user ID and update them as well. So if I refresh my data over here, I can see they now have an age of 1. I'll grab some other user with an age of 0, edit them just to grab their ID, and then we'll bring that ID over to Visual Studio Code. From here, I'll swap out the old user ID with the new one. I'm going to save the program and rerun it a second time. This time, we're going to see that the count is now 2. There are 2 users with the age of 1, the one I had changed a few moments ago, and the one that I changed just now. So right here, we can see how we can use promise chaining to do one thing after another. Now let's wrap up by talking about this deprecation warning that we're getting right here. Deprecation warning, collection.find and modify is deprecated. Then it offers up some alternatives we could use instead. So find and modify is deprecated because there's better alternatives and it's eventually going to go away. Now, this is not something we ever typed out in our code. It's actually coming from the MongoDB native driver that Mongoose is using behind the scenes. So the MongoDB native driver will change how things get done. They'll deprecate old methods and introduce new ones. And it takes Mongoose a little bit of time to get up to speed. So you'll see these warnings every once in a while. Now, it's very possible you're not even seeing this warning. That's okay. If you are, you can always address it by going into Mongoose and setting up another option similar to what we did with use new URL parser. That means we'll be setting up a third property on this object, and this one is called use, find, and modify, and that is set to true by default. We're going to set that to false, which will address the deprecation warning until it's addressed by default. Now, if we save mongoose.js, we can go ahead and rerun the script down below by shutting it down and starting it up once again. And now we have no deprecation warnings in sight, which is nice. So at this point, we got a basic rundown on promise chaining. It took a little while, but I wanted to go through 2 examples. One using fake asynchronous operations with set timeout, and another using real asynchronous operations. In the next video, there'll be a challenge where you're going to have to use promise chaining on your own. I'm excited to get to it, so let's jump right in.